In this video, we will be discussing how to simplify radicals by rationalizing. If the denominator doesn't work out to be a perfect square number, then you may need to rationalize. To rationalize the denominator, it means to have a rational number in the denominator, or that's just a fancy way of saying get rid of any radicals that may be in the denominator. So a rule of thumb is that if there is a radical in the denominator, it is not fully simplified. So we cannot leave our answer like that. So we're going to follow 3 steps to rationalize and get rid of any radicals that may be in our denominators. So the first thing you're going to do is you're going to check for perfect square numbers, because sometimes you'll notice they're perfect square numbers, so you can simplify them right away, and that will eliminate any radicals in the denominator. If they're not perfect square numbers, then we're going to move on to step 2. So if you still have a radical in the denominator, then you're going to multiply both the numerator and denominator by the radical in the denominator. And that's how we're going to eliminate any radicals that are still left in the denominator. And then once you do that, step 3, you're going to look to make sure that you simplify completely. Sometimes you can continue to simplify even more. Alrighty, so let's practice with some examples. So in example 1, I noticed that I have the square root of 25, and that can be reduced right away. The square root of 25 just becomes 5, and then I'm going to keep 2 in the numerator. I can't reduce 2 over 5, so this is my final answer. In example 2, I have the square root of 3. I can't reduce the square root of 3, so I need to get rid of it. So to get rid of it in the denominator, remember step 2 says to multiply the numerator and the denominator by the radical you want to get rid of, which is the square root of 3. When I'm multiplying, remember you multiply outside number times outside number, inside number times inside number. So careful with the numerator, because the outside number with the square root of 3 is 1. So we can only multiply the 7 and the 1 together to get 7 square root 3 in our numerator. In the denominator, both of the 3's are underneath a square root. So I can multiply 3 times 3 to get the square root of 9. Now I can simplify this more, because the square root of 9 just becomes a 3. And then in the numerator, I have 7 square root 3. And then the last thing I want to double check is, can I reduce these outside numbers, this fraction 7 over 3? I can't. So I'm just going to leave it then as 7 square root 3 over 3 as my final answer. In example 3, when you see an entire fraction underneath a square root, that's the same thing as dividing it into 2 square roots. So this is the same thing as the square root of 49 over the square root of 64. I notice that both of those numbers are perfect square numbers, so I can take the square root of 49 to get 7, and the square root of 64 is 8, and then I can't reduce 7 over 8, so that's my final answer for example 3. In example 4, again, we have an entire fraction underneath a square root. So I'm going to break it up into 2 square roots. So square root of 7 over the square root of 9. And then there's a 5 in front. So the 5 is technically, if we write this as a fraction, 5 over 1. So notice I'm going to be putting the 5 on top with the 7, and then you could put the 1 on the bottom with the 9, but I usually don't write a 1, so I'm just going to leave it like this. And then I notice that I can reduce the square root of 9 to 3. And then in the numerator, I would have 5 square root 7. I can't reduce 5 over 3, so I'm going to leave my final answer as 5 square root 7 over 3. In example 5, I can't reduce the square root of 3, so I need to get rid of it. So again, to get rid of it, I'm going to multiply the numerator and the denominator by the square root I want to get rid of. In the numerator, remember the 18 can only get multiplied by the outside number. So I have to multiply 18 times 1 to get 18 square root 3. And then in the denominator, I can multiply the 3's together since they're both underneath the square root. So I get square root 9. Then I notice I can reduce the square root of 9 to just 3. And then in the numerator, I have 18 square root 3. And then I notice I can also reduce now this fraction. 18 over 3 reduces to 6, and then bring down the square root 3. So my final answer for example 5 is just 6 square root 3. In example 6, I notice I can do some reducing. So for this example, I know that the square root of 4 is just going to become 2. So in the denominator, I'm going to have 2, and then I'm going to multiply that 2 by the 5 that was in front. And I'm going to keep 10 square root 2 in my numerator. So 5 times 2, I end up with 10 in the denominator, and then I have 10 square root 2 in the numerator. 10 over 10 is just 1, so the 10s actually cancel each other out. So my final answer for example 6 would be square root 2 or 1 square root 2. Let's try a few more examples now on the back page, just so you can kind of get the hang of this. So in example 7, I know I can't reduce the square root of 3, but I also can't leave it in the denominator. So to get rid of it, I'm going to multiply the numerator and the denominator by the square root I want to get rid of, which is the square root of 3. The 6 can only get multiplied by an outside number, so 6 times 1 would be 6 square root 3, and then I can multiply the 3's in the denominator to get square root 9. I know the square root of 9 is just going to become 3, and then in the numerator, I have 6 square root 3. I also notice that I can reduce this fraction. 6 over 3 just reduces to 2, and then bring down the square root 3. So 7, you should get 2 square root 3 as your final answer. In example 8, again, if you have an entire fraction underneath a square root, you can break it into 2 square roots. So I get the square root of 9 over the square root of 2. I know I can reduce the square root of 9 to just 3 over the square root of 2. And then I can't leave that square root of 2 in the denominator, so I'm going to multiply both the numerator and the denominator by the square root I want to get rid of. In the numerator, you can only multiply the 3 by the outside number. So 3 times 1 is 3, and then bring down the square root 2. In the denominator, I'm going to multiply 2 times 2 to get the square root of 4. And then I notice I can reduce the square root of 4 to just 2. In the numerator, I have 3 square root 2, and I can't reduce the 3 over 2, so this would be my final answer for number 8. In number 9, I notice I have 2 really large square roots, and so you can change this back into a fraction, a whole fraction, 96 over 12, and you can reduce that square root you can reduce that fraction in your calculator, because 96 divided by 12 just becomes the square root of 8. And then I notice I can reduce the square root of 8 because 4 goes into it. So this would be square root 4 times square root 2, which would reduce to 2 square root 2 as the final answer. In number 10, I notice I can reduce the square root of 144. I cannot reduce the square root of 17, so I'm just going to leave that. The square root of 144 is 12, and this would be my final answer. In number 11, remember that if there is a number in front, put it over 1. And then I'm going to break up my square root into 2 square roots. So I have square root 1 over square root 4, and then make sure you put that 2 in the numerator. I know that the square root of 1 is just going to become 1. So I'm going to do 2 times 1. And the square root of 4 is just going to become 2. And then I can cancel out 2 over 2. So my final answer would just be 1 for example 11. Last example, example 12, I can't reduce the square root of 5, but I can't leave the square root of 5 in the denominator. So remember, to get rid of it, I'm going to multiply the numerator and the denominator by the square root of 5. In the numerator, I can only multiply the outside numbers together. So 3 times 1 is 3, square root 5. And then in the denominator, I can multiply 5 times 5 to get the square root of 25. I know that the square root of 25 will just become 5. And then in the numerator, I have 3 square root 5. And I can't reduce the fraction 3 over 5. So this is my final answer for example 12. Rationalizing square roots is probably one of the more challenging topics from this unit. So we're going to spend a couple days practicing different examples, but feel free to reach out to your teacher if you have any additional questions.